Welcome everyone to the Tillicum onboarding training. Tillicum is our new GPU cluster at University of Washington on-premise. It's almost directly below us in the data center here at UW Tower. And the GPUs down there are just screaming. They're just going, going, going. So we're so excited to put them to work here with you this morning. My name is Kristen Finch, and I'm Director of Research Computing Solutions. I'm joined today by Kaichen, who is our HPC staff scientist. She'll be leading part of the training a little bit later. And also we have some staff members in the audience who can help us. Xiao Zhu is our Associate Vice President for Research Computing at UWIT. Rob Fotland is here also as a participant, and he is our Cloud Computing Director. And online, we have Samaya Sathar, who is our technical product manager, and Namfo, who is our HPC and cloud architect for our team. They'll be helping with the online questions that you have. Okay, so today we have provisioned you a Tillicum computing account, and we're going to talk about how to use that. You have access to this account until Sunday at midnight. So go nuts, okay? Really. You have access to do the tutorial on your own, but also you can feel free to explore as you will for whatever you want to discover on Tillicum. You will have to have your data moved off. So if you have any data that you are happy to take with you, we'll be talking about data transfer. There are instructions for that, and we want you to have all of that moved off by Sunday at midnight as well. Additionally, if after this you are needing some help or you're still just keen to keep on discovering new things on Tillicum or on our other cluster, Hayat Cologne, we have office hours twice a week. The first one is on Tuesdays at 2 p.m. on Zoom. And the second one is on Thursdays at 2 p.m. in the eScience Institute. And eScience Institute also offers office hours throughout the week for different topic areas. And we have some other eScience affiliates and staff in the room as well. Could you raise your hands just in case you have? They're over in that corner. The team is over there. So if you have any questions about eScience, we also have representatives here for you. So everything I just said will be in an email following this, so you don't have to remember it, and all the links to sign up for all the coming events, find out about eScience, and the office hours will be delivered to you after this meeting. All right. So I will go ahead and get started. The way that this workshop is going to work, we're doing a little bit different structure this time. I'm going to, and Kaichen is going to go over the topics that are the most important, in our opinion, to getting started on Tillicum. So logging in, file system, file transfer, Slurm, modules, computing environment, and our on-demand platform. And we're going to do this in kind of a presentation style by showing you the workshop resources. But then the second hour, we will be having a task that you'll be doing independently on your own. And this task wraps all of those skills into one. And then our staff will be here walking around and helping you be able to do that. So I'm going to walk through some of these things in the terminal, and you can follow along, or you can try and go with me as I go, typing in the commands. But if you fall behind, or you miss something, or you need to take a break, then you'll be able to have access to all of this through the weekend, and also we'll be here for the second hour to do a lab session. All right, so I will say a reminder for folks joining remotely that in the second hour, you will want to have your VPN connection established. And any of you that are going to be working on this from home that is outside of the campus internet network, you'll want to have the VPN established to use the Jupyter section that we're going to demonstrate. Okay. And the VPN sections or instructions for setting up the VPN can be found here. The GitHub repository, if you all want to follow along, is github.com/UWRC Tillicum-onboarding. All right. I'll take a minute to put that into the chat so that you all can get there with me. So the first step of working on Tillicum is logging in. One requirement of logging in is Duo two-factor authentication. And so I'm sure as the UW community members, you all already have this established and set up. But you have a few options. So you can use the terminal on Mac OS. You can use Windows PowerShell. You can install other programs like PuTTY or Git Bash. I have a Mac system here, so I'm going to go ahead and switch over to my terminal. And the way that we log in is SSH with your UWNet ID minus Finch KN at tillicum.hyac.uw.edu. And I execute this. It's going to show me a key, and it's not going to put the characters or show you the password, which means it's safe for me to be sharing my screen. But you won't see the typing, so it might throw you off. But you're gonna put in your password next. It's the same password for all of your UW services. And then you will see the message of the day, which shows you that you're logged into Tillicum, and it tells you that we have a help desk and also that we put the system under maintenance every 2 weeks on every month on the second Tuesday of the month. So you are now in your shell. This means that you're looking into Tillicum and that you can access the command line interface of Tillicum now. So now you are in the supercomputer Tillicum. Congratulations, welcome. And your shell prompt tells you a little bit, tells you who you are and where you are. So I'm Finch KN and I'm logged into Tillicum login 2 or login 1. You might be in login 2, but most of you are probably in login 1. And this tilde means that I'm in my home directory, which we'll talk more about. That's the directory that you always are starting in when you log into Tillicum. If you use the command print working directory or pwd, it will show you the address or the path of that directory, GPFS, home, Finch KN. You should have GPFS, home, and then your UWNet ID. If you ls-l, you can see you might not have some files in there yet if you're a brand new user, but I do. So it shows me the long format of the files that I have. And then if I use hostname, it just shows me again that I'm on Tillicum login 1. So that is logging into Tillicum. I'll keep moving forward. You'll have a chance to try this out on your own. So navigating the file system, a little bit about Tillicum. If you have used our HIAC clone system, it has a little bit different structure. So the parent directory of all directories in the Tillicum file system is called root, but it is shortened to just /. So it is the directory from which all directories do come. And so it is structured this way as a directory tree. And our main mounted file system, so most of your files on Tillicum are going to be stored in GPFS. This stands for General Parallel File System. And so if we say in GPFS, that's how you know that you're in the mounted fast file system for Tillicum. This is where you want to have all of your active computing files because they will be ready to go when you need them. So if you see a path like this, /GPFS/home/your UWNet ID, you know that you're in that mounted file system. From there, we have our home directories, which is where we've been talking about this whole time. We have dedicated project storage, where if you have an allocation on Tillicum, you will have your groups storage. We have scrubbed, which is our temporary storage, which we'll be using for this tutorial. This tutorial doesn't come with dedicated storage. If you want dedicated storage on Tillicum, then you will need to have an allocation. we have some software and some common data sets. So if you and your whole research group know that you're going to be using Tillicum and you're going to be just like pounding against the same data set over and over, and maybe other folks at the university will want to use that as well, we have a nomination system for our data commons data sets. All right, and the main things that you need to know are your quotas and how to manage your storage on Tillicum. So the directory that you just spawned into, your home directory, this directory only has 10 gigabytes of storage. So we recommend only keeping your essential configuration files and nothing else in this directory. If you fill up this directory, you are quickly stopped from doing anything else on Tillicum. And you will send us a ticket and say that you have exceeded your disk quota, and we will help you through that. But we'll also remind you that this only has 10 gigabytes of storage. Your project storage, if you do sign up for an allocation with Tillicum, will have 1 terabyte of storage. This is where you should store your Tillicum code spaces, your Conda environments, any files you need to share long-term with your group. Those will be stored there. These are backed up. So we have daily snapshots on the home directory and on your project storage. But our scrubbed storage, this is where you want to do the most of your work. So you'll be moving data in and out of Tillicum as you're ready to go for your research computing projects. You have a 100 terabyte limit per user, but if you don't use those files, they're going to erase themselves in 60 days. Okay. So not a good place for your Conda environments or any software that will break if stuff starts disappearing, but great for storage that you need to do your work and then relocate those files after. We have options for PIs who are interested in a storage space that can be used to offload those files. We have great systems for that. Yes, but for today, we will put them in the scrub storage. So, yep, we'll go over that. All right. So there are some practice things in here. I already went over these ones. All right, we're going to get our working directory set up for the training today. So back in your terminal, we're going to go over to that scrubbed storage space where I want you to be working from today and throughout the weekend. So you're going to change directory or change your location on the store or on the file system to GPFS. Remember, that's their mounted file storage /scrubbed. And now if we ls-l, we can see everything that's in scrubbed. So we did have some early users that were in here working, including myself and Kaichen. So I already have a directory for myself, but I'm going to go ahead and make a new one and just call it Kristen F. I've called it Kristen F. No one else can. I've claimed that one. So use your own name. Use your net ID is probably the best method and make your directory there. Change directory to open it. And you will see that it is empty. But we are going to clone the Git repository so that you have that for yourself on Tillicum as well. So we have Git installed natively. So the command is git clone. And then if you do have the notes open, you can just copy this address directly. https://github.com/uwrc/tillicum-onboarding.git. And now if I ls, I have a directory with the Tillicum onboarding files. So if I cd Tillicum onboarding and ls, then I see the files that we have been talking about this whole time, which we will be using later. Let's do print working directory just to remind us of where we are. So we were in our home directory and we came over to GPFS scrubbed and then our own directory. And then we made a directory for ourselves called Tillicum onboarding. If I wanted to quickly jump back to my home directory, I could do cd and the tilde. So the tilde is like a little shorthand to go back to my home directory. That's where I am. And if I can quickly with tab complete go into my directory again. And then if I cd dash, that also will just take me to the very last directory that I was in. So I'm back in my home directory again. And if I do cd dash, it takes me back to where I was before. And then I can enter Tillicum onboarding. Okay. Great. So I just helped you put some files from the internet into Tillicum, but those are not your files, right? So you will want to have your files into Tillicum, and I'll discuss with you how to do that. So one of the fastest ways to do that is to use the SCP command, or secure copy protocol. I also think of it as server copy. So we're just like copying to the server. And so this is great for small or medium file transfers. It's really not great for very large file transfers, where if your internet connection wavers, then that just stops and you don't really know if it completed or not. Not so good, but it's simple. It's available on all systems. And so I'll tell you how to do that. One rule is that you have to be in a terminal on your local computer to be able to send files to Tillicum or take files back. You're not in Tillicum like pushing them to your computer, because that's just not an allowable protocol. Okay. So I'm going to open up a new window. And if I just ls, I'm in my home directory of my computer. And so let's see, I have a test.txt, which is just an empty file that I use for trainings. So if you have something that you're fine transferring to Tillicum, you can follow along with this, but the command is to run scp, and then you run that file, so test.txt, or you provide that file name that you're going to be transferring. And then you're going to be using your UWNet ID at tillicum.hyac.uw.edu colon slash, and then we're going to put that path where we want that file to end up. So we can start out with /gpfs scrubbed Kristen F Tillicum onboarding. And it asked me for my credentials again, as it should. And now if I flip back to my other terminal that has Tillicum onboarding, or is in Tillicum and shows my onboarding directory, if I ls-ltr, it will show me the long format of the files that I uploaded most recently, or that I modified most recently. And there is test.txt is here. But what if I want to pull something out of Tillicum? So what I did was I just sent something to Tillicum. And what if I want to pull it back? If you use the up arrow, I can get that same command back, but I'm going to change it a little bit. So I'm going to use Control A to jump to the top, or you can use your mouse. And I'm going to delete test.txt. And the way to start off this command is to do scp, and then you do your login credentials. Oh, of course. Sorry, I'll just start again. scp Finch kn at tillicum.hyac.uw.edu /gpfs/scrubbed/Finch kn. Oh, sorry, that's my other one. Kristen F Tillicum onboarding. And then let's see, what can I pull? I'm just going to grab this job.slurm. Next thing that you have to do is you have to tell it where it should go. It doesn't know yet. Your command is incomplete. So if you just do dot, that means put it right here where I am in my home directory on my local computer. Same thing. Pretty simple, right? So what's the number one rule? When you're using SCP, you have to be doing that from your local computer or it won't work. But this isn't fun. Like, what if I have big files and I don't want to like wait and dedicate my computer to this? Well, that's the whole point of research computing. It's the whole point to use Tillicum is that you want to gain your life back by having a job scheduler and by having a place to store big files and work on them. And so we have a service called Globus that actually allows you to do these file transfers. It checkpoints them, so it makes sure it does kind of like checks the phases, and it's making sure that the entire file is getting transferred, and it emails you when it's done. It's doing this all unsupervised, so you don't have to be staring at your computer to see if it is working. So I'm already logged in. This is one that you probably should work on your own, but you'll be able to log in with your UW credentials, same password and everything. You can find UW Tillicum, and you can navigate the file system in the same way. Scrubbed. Kristen F. Tillicum onboarding. And if you use the two-pane view, you can load your Globus personal. I've set up a Globus Connect personal endpoint on my laptop. You all probably haven't done this yet, and you should do it on your own. After this session, we have walkthrough instructions to do that. But it allows me to do the same thing. So on the right panel, I have the home directory of my personal laptop, and I have Tillicum on this side. If I go over here and I want to transfer this markdown file from Tillicum to my laptop, I just push the start button, and it tells me that the transfer is started. I can go to the details, look at the event log. It's already succeeded, and I've gotten an email about that, and I won't show you my messy inbox to prove it. So that is the way that I recommend to transfer anything to and from Tillicum. If you are a Hayat clone user, we have Globus set up as a endpoint on clone as well. And we have Globus set up on our file system COPA, which I think is your great medium tier for offloading your data on Tillicum when you're done using it. Finally, we also are working on releasing our UW OneDrive connector for Globus as well. In our development of Tillicum, or actually Microsoft made a change to their accounts, so it has gone away even though we released it last month, but it will be back, so stay tuned for information about that. You have 5 terabytes available to you for free as UW student, employee, staff member on OneDrive with Microsoft. I don't know if you know that, but everyone should be taking advantage of that. And you can transfer back and forth to Tillicum or Hayat clone using this service. All right, finally, I'm going to talk about Slurm, which is our job scheduler. You will have plenty of time to practice this, so I'm going to go over the broad concepts here, and then we're going to switch into our next session. Or I'm going to switch places with Kaichen. She's going to come up here, continue talking. Okay, so we have one rule, another rule, I guess I've been saying a lot of rules, is that you shouldn't be running any hardcore processes on Tillicum login node. This is the front door for everyone needing to get into Tillicum, do code development, move data parsing, move around files. And so it's not permitted to do any computing on the login node. You should be, if you're using Tillicum, taking advantage of the GPU nodes to accelerate your research. That's the whole point of this, right? So we have a job scheduler called Slurm, which stands for Simple Linux Utility Resource Manager. Except then they decided that it's not very simple. It's actually quite complicated. So they stopped using the acronym and it's just called Slurm now. So there are 2 types of jobs or 2 kind of workflows that you would be using Slurm for. One is to work interactively. So you need to test out some code on a GPU. You can provision that for yourself with a command called salloc. Bring up one GPU, run some tests, make sure that your GPU is going to be firing off, and you can use NVIDIA SMI to confirm that. This is what you want to use for your interactive jobs, so any active computing. But if you have jobs that are ready to go, you've got your scripts, you can just like get it ready, shove it off a cliff, and you want to go to lunch and come back when your results are done, that is what you're going to want to use your batch job for. So this is for long or unattended jobs, and the runs are automatically, they run automatically when the resources are available. So you can just submit them and wait. You can even set it up to email yourself when it's complete. If you are a Hayat clone user, you will notice that there are some differences in how you're going to use Slurm on Tillicum. So Hayat clone, you have a dedicated resource, or you're using the checkpoint, which is our community idle resources. This system doesn't exist on Tillicum. Tillicum is pay as you go, and everyone has the same priority. So you just submit your jobs, and whenever the traffic is clear enough to provision your job, then it is available to you to do that. But you have some choices on the types of queues, or QoS is quality of services. I just think of them as queues, where you would send different types of jobs. So we have the normal queue. The maximum runtime is 24 hours. You can run a maximum of 16 GPUs simultaneously. This doesn't mean that you need to have 2 nodes, each with 8 GPUs going. You could have 16 jobs, each with 1 GPU instead, right? So it's a collective sum total of 16 GPUs running simultaneously. That's your limit. And if you've reached that limit, you can keep on sending your jobs. They'll have to wait until more resources become available. Some of your other jobs complete. Oh, I said that wrong. So the maximum job is you can run 16 GPUs. The concurrent GPU limit is actually 48 GPUs. So I said that wrong. It's way better actually than what I was just saying. So you can run 48 single GPU jobs concurrently. That's a lot of power, especially with the H200s, which each have 141 gigabytes of RAM. If you need a quick test, you can use the debug queue. 30-minute time limit, you can only have 1 GPU. This is just to test it out, right? You really should probably only be using that interactively. We also have interactive QoS. I think we might have this not at first, but we might increase the priority so that you have that when you need it to be able to run jobs interactively. Maximum is 8 hours, 2 GPUs, and only 2 jobs running concurrently. So this is for real-time debugging those longer jobs. You're working interactively. And then we're going to be opening up a long queue, so a longer runtime, and a wide queue with even more resources than are available on these other queues. But those are going to be by request only. And we are going to ask for some data to demonstrate that you can make use of all those GPUs that you are reserving for yourself. The runtime, or the cost, is 90 cents per GPU hour. This is multiplied by the elapsed time, or the time used on your job, times the number of GPUs that you requested. And Slurm will print a nice estimate of how much money this could potentially cost you if it ran for the entire time that you requested. If your job completes before that time, your charge will be less. One of the best things about Tillicum is when your job stops, you are stopped being charged. There's no like things running in the background that are running up your bill, right? That's not the way it works here. All right. I need to switch over now to Kaichen. She is going to demonstrate we're going to go over the types of jobs in the task that she has prepared for you all. And so I'm going to switch over now, and those will be explained in the future. You'll have plenty of time to practice. Okay. You want to share your screen? Are you in the Zoom meeting? Okay.
Okay, hi everyone, I'm Kaichen. Thanks, Kristen. We have go over the basics for the Tillicum system, and you already know how to log in and explore a little bit of the file system, and know how to transfer files between your local computer and okay, yeah. So we already go over the basic concept for the Tillicum system and know how to log in and explore the file system a little bit and know how to transfer files between endpoints and the basic concepts for Slurm. So next I'll cover the 3 sessions for to explore more about the computing environments on Tillicum. So Tillicum uses the LMOD environment module system to manage software. Each loading module will dynamically update your environment variables. The most important one, the path and the library path. So the corresponding executables and libraries become available. So to understand, first we want to understand the environment, the shared environment on the cluster. So when you log in, your shared environment combines the system defaults that defined by us, the environment variables and the functions. They are defined globally for all users. And the user customizations, that's the variables and layers defined in your startup files. Those stored in your home directory, the bash RC and bash profile. And then those are all hidden in your home directory. And the modules that is the software environment modifications from any loading modules. If you want to explore more of the environment variables, you can print the path and the library path. Those are the directories that the system will look for, will search to for the executables and libraries. And the thing that I want to focus on is the module system, the LMOD module system that used by Tillicum. So it is an implementation of the environment modules that easily handles the hierarchical module path. We list some commonly used the LMOD command here. Let's go over to the examples. So the first thing we want to know is the available module on Tillicum. So that can be achieved by using the command module avail. So you will see the core modules on Tillicum. This will only list the module that visible in your current session. So the output actually, it might be quite long depending on the number of module files. And you can see that for each module, it's the full name include the software or the package and the version. So for the same package, it can have multiple versions. To narrow down the results, if we are only interested in a particular package, then we can use module avail the name of the software. So it will only show you the available GCC compilers on our system. But the module avail only show the visible results from the current session. If we want to search the all module hierarchies, even the ones that are not currently visible, we need to use the command module spider. So for example, we didn't see any CUDA package here. If we want to find out all the available CUDA versions on Tillicum, we could try CUDA spider. Oh, no, sorry, module spider. CUDA. So in that case, it will do a deep search throughout the module tree and show you all the available CUDA modules on Tillicum. And it will give more details of the module, including the dependencies. Oh, no. Here, if you want to know more details about a specific version, then for example, we can copy this command to module spider CUDA with the specific version. It will show you more details here. For example, the prerequisite for CUDA. So if we want to load CUDA, we need to load GCC 13.4 at first because that specific CUDA is built on top of the compiler, the GCC 13.4 compiler. So the thing I want to the thing to know here is that module spider will be the most reliable way to see all install software and learn what prerequisites must be loaded first. So we would recommend always using module spider instead of module avail to find out how to module load. Then I mentioned hierarchy structure several times. Tillicum uses the hierarchical module structure to ensure the compatibility between software stacks. So there is an explanation here, but I think the most straightforward way is to just show you how to load the modules. So for example, if we want to load a module such as Open MPI built with a specific version of GCC and CUDA with CUDA support, then we need to load the compiler. So for example, module load GCC. If you don't specify any versions, it will load the default version defined by the system. So in that case, if we run module avail again, one more session will be added in the available modules. That's the software stacks that dependent on GCC we loaded. So here you can see that the specific version of GCC, which is GCC 13.4, and it's marked by L for listed or for loaded and D for default. Then we can load the CUDA version here. So for example, the CUDA 13. In that case, if we do module avail again, it's not the default CUDA version, I think. So we can see all loaded module with module lists. So we don't want CUDA 13 right now. I think I want to load the other version of CUDA. In that case, if we swipe different versions of the module, then it will show you that it will unload the previous version and load the version you specified. And if we run module avail again, you will see one more session being added. That's all the modules that built on top of GCC 13.4 and CUDA, the CUDA version we have loaded. In that case, we will be able to load Open MPI. And we can list all loaded module with module list. So to know the prerequisites for Open MPI, we can use module spider. It will tell you that you need to load GCC 13.4 and CUDA 12.9.1 before we are able to load Open MPI. Okay, so that's the basic information for the software stacks on Tillicum. And then I want to switch to the next topic for the computing environment. Actually, Tillicum provides a flexible software environment for research computing. And in addition to module, we also support the obtainer containers on our system. But here I will just focus on how to build a custom computing environment using the minimal Conda module provided on Tillicum. So Conda allows you to create isolated environments on the Tillicum that include specific versions of Python libraries and tools. So we already see that there is a Conda, central Conda module on Tillicum. So first we want to load Conda. A help message will show up after we load Conda, so you can read this through later. And with the Conda module loaded, the Conda commands will be available. We can now create and manage our own Conda environments. I won't demonstrate this here, but you will need to do this yourselves in our task. So we can create and manage Conda environments with Conda create and activate the environment after we created it and list all available Conda environments. And when you are done, you can remove your Conda environment. And the most important thing I want to note here is by default, the system Conda stores environments and packages in your home directory. but we recommend to install Conda environments in your project directory, or in the case today to install them in the scratch. Because we, as Kristen mentioned, that we only have 10 gigabytes in our home directory. So that's almost the most tickets received regarding the home directory, that people install everything in their home directory. So that's something we really want to avoid. And to customize the environment and package locations, there are two ways to specify where your Conda environments and packages are stored. The simplest way is just to use the prefix arguments to set the full path to your Conda environment, and always activate your Conda environment with full path. So the codes are provided here. But a more permanent way is to configure the defaults that's saved in the Conda configuration file .conda.rc in your home directory. To make this the default behavior, you can edit the file with the following to include the following lines. This will place all of your environments on package cache in the directory specified in the configuration file by default, and you won't have to worry about specifying the full prefix to your environment. And within Conda environment, you can use pip to install Python packages. But we suggest that always use pip inside the Conda environment. Otherwise, if you install packages globally, it may cause some problems or conflicts between your different environments. Tillicum also supports Apptainer containers for running portable, reproducible software stacks. We highly recommend using containers to build your software environment on Tillicum, especially in the case for GPU workflows that with complex dependencies. NVIDIA provide pre-built containers with CUDA and NVIDIA drivers configured, so those work well with the Tillicum environment. If you're interested in those parts, we will hold separate hands-on training sessions for building and running containers on Tillicum. Please check out our calendar for the upcoming training events. And the last part I want to cover is a really useful tool provided by supported by Tillicum. So Tillicum provide Jupyter Lab and Jupyter Notebook, as well as more upcoming tools such as VS Code or RStudio through Open OnDemand. Please note that if you are off campus, UW VPN is required to access Open OnDemand. So Open OnDemand is a web-based portal that provides an integrated single access point for remote HPC cluster. If you click on the link here, it will redirect you to the Open OnDemand web portal. So I think I already logged in, but I think you may need to log in before getting to the main page of the portal. So Open OnDemand allows us to achieve a lot of tasks, such as exploring the file system. It's more like in a graphic interface. You can upload. It will show all your accessible storage space, the projects, and my folder in the subscribed folder, and also my home directory. You can upload, download, edit or delete your files on Tillicum. And also you can monitor your jobs here. And we also provide the interactive apps. Right now, only Jupyter is available, but more will be added later. And it also provides us with a virtual desktop with the graphic interface, and with a terminal. Yeah, you can log in to use the terminal here. So this is the virtual desktop that if you want to run some software such as MATLAB or Console, then they can be run with graphic interface easily through Open OnDemand virtual desktop. Yeah. So yeah, different. I will show you to launch Jupyter Lab here. Yeah. So we can run Jupyter Lab. We recommend using Jupyter Lab, but you can also run the classic Jupyter Notebook interface through Open OnDemand interactive apps. So to launch the when we are done with jobs, so always remember to delete the jobs. Otherwise, it will run in the background and count to your project usage. So to launch Jupyter Notebooks or Jupyter Lab, click on interactive apps on Jupyter. You will be prompted with a form to fill the information for Slurm job. Actually the background is an interactive Slurm job running on Tillicum. So you need to select the account for you. It should be train or onboarding OB 2025, and then the quality of service is interactive. Number of GPUs, we keep it as 1. Number of hours, we can use 1 or 2. And then the user interface by default is Jupyter Lab. If you want, you can also change it to Jupyter Notebook. And if you want to have more custom choices, you can modify the Jupyter command line options or Slurm command line options. You can explore this more later. Yeah.
When I launch Jupyter environment, the Jupyter instance, is it inheriting a Conda environment that I activated?
No. So here is built on a minimum environment for a minimum module for Jupyter, and you will be able to switch to your custom kernels after you launch the Jupyter Lab, or then switch. Yeah, I will demonstrate that later. Yeah, so click on launch, and then you. Okay. Mm-hmm. Yeah, that's the important part for part for the Tillicum cluster, that we restrict at least one GPU be required when you request a job. So if you want to use CPU, then you can use our other cluster, the clone cluster. So for Tillicum, we always need to specify at least one GPU. Yeah. Yeah.
And 100 gigabytes of system RAM in addition to the 141 gigabytes on the card.
Yeah. So thanks, Kristen. So that is also shown here, that it will show how many resources you have requested. So for example, I only request 1 GPU, so it should be 1 node, and it comes with 8 CPU cores. Yeah. And also I request for 1 hour. And after we click launch, it will bring us to the working card here for our job. And it may take some time for the system to allocate the resources and initiate the process. We may need to wait for some time, but once the resources are ready, you will see a button appear here. Click connect to Jupyter. So click on the button. It will bring us to the launcher tab of the Jupyter Lab. So if we want to open a new notebook, then actually we have choices of different kernels here. There is the default one is the minimum Jupyter module, and there is some pre-built ones, the data science one. And Hugging Face actually is my own custom environment. I have registered it as a kernel, and we can also register a container as a kernel. So if you click on any of this, it will create a new Jupyter notebook with the kernel you selected. To switch the kernel, you can either go to the kernel and change kernel, or you can just click on the name of the kernel at the upper right corner to switch the kernel in the drop-down box. Let me see. Yeah, to register your custom Conda environment as the Python kernels, you will need to do all of those following steps in a terminal on Tillicum by load the Conda module, activate your environment, and please make sure you have the IPython kernel package installed in your Conda environment, and then register your environment as a as a Jupyter kernel. By running the ipkernel install command in your activate environment to set up the Jupyter kernel specification. And please note that here the name argument will take the internal environment name we used for our environment, and the display name will be the name appear in the Jupyter kernel. So it should be this one. Yeah. And after we finish, close the tab, and you may need to save your work. I don't want to save it, so I just click on, and then close the tab, back to the Open OnDemand portal, and remember to delete your job to terminate the job. Otherwise, it will keep running and consume resources and maybe money. And if you want, you can also remove your Conda environment from a terminal. Okay, so that's all the concepts we want to demonstrate before we turn into our hands-on sessions. So, but before that, I want to briefly go over what the hands-on tasks. This hands-on exercise will guide you through all the essential concepts we have demonstrated for using Tillicum. You will create a working directory, which you already done so, and start an interactive job, load modules, build a Conda environment, run a simple Python code, and submit batch job, and finally connect that environment to Jupyter Notebook. So you can skip the first step, you create your working directory if you already done so. And then start an interactive job to run the Python code. Because please remember, all compute work must run on a compute node. Don't run them on the logging node. And once the resources are ready, please load the system Conda module and create your own environment. And then run a simple Python script. That's a daemon script that provided in the training repository. You can find that in your repository cloned on Tillicum, but the name is Tillicum demo.py. And then run it with the command provided here, and check the results from the console that provided here. You should see something similar to the one provided here. That verifies the TensorFlow is ready and can detect and use your GPUs. And after that, we want to deactivate your environment and exit or terminate your interactive shell, and then submit a Slurm job to run a batch job, submit a batch job. And before that, the Slurm script is also provided here, but you will need to modify the path, the Conda activate path to your own actual Conda environment full path, and run the and after the modification, you should be able to submit your batch job. And you can check the status of the job, and when the job finished, you can view the results. Oh, I'm sorry, I think the comma here is wrong. So you need to substitute after the last underscore, it should be the job ID of your own job. And then register the Conda environment for the Jupyter Notebook. And please make sure to have the ipkernel package installed and register your environment. And following the steps we covered in our demonstration to launch the Jupyter Lab from Open OnDemand, and switch the kernel to the kernel you just registered, and also test your environment by copying and paste the code snippet here and run the cell by Shift Enter. And don't forget to clean up the Jupyter jobs and also your environments. So that's the task you just try to run for the following hands-on session. Yeah. No. Yeah. So yeah. So you only need to end the session to stop the charge. But usually we don't need to remove our environment actually, but in this case, because it's just a test, it's just for testing. So I want you to practice how to remove the environment. But if you have an active environment that you are working on, then especially if you store that in your project directory, then usually we don't need to remove it, and you can reuse it whenever you want. Yeah. Okay, that's all. And we can have a break before the hands-on session.
Yeah, thank you. We're going to have a quick break, and then we're going to be here for the next hour. You have the entire weekend to complete this on your own, and the instructions are here. Please, if you want to save any of this, work product, then use Globus and walk yourself through that tutorial to move your data off and elsewhere. So before, if you all are going to leave and do this on your own, that is fine. We will be here to support you for the next hour. I do want to point out that posted around the room, there is a QR code to a feedback survey, and we'd love to hear your feedback. One of the questions is, what trainings you also want to see that would help it be easier for you to use Tillicum or Hayat Clone this year. And the feedback survey will also be sent in the email along with all the materials. We had one question in the chat that I thought was interesting. So some of the workbooks or the sessions that we lay out for you, they demonstrate how to use your dedicated project storage. So that's only available if you are an official Tillicum customer, which you all are training early access kind of customers for this demonstration. So you'll only be allowed to use GPFS scrubbed where you built your directory. But for PIs that do sign up, your first 100 GPU hours are always free. And then you and your research lab have that dedicated project storage to use for computing on Tillicum. Okay?